Welcome to the channel Professor Davinci. Tree representation. So tree is a data structure you know very well. So let me draw the tree. So this is the tree. Okay. I erase the extra things. Okay, right. Tree is a data structure, a non-linear data structure. We can represent tree in a three different ways: array representation, linked list, and left child, right sibling. Last video, if you remember, we have seen the tree representation by array. We have seen tree representation by array. Now we look into this one, linked list and a left right sibling. Clear? Now let's jump into the topic. We have seen already array. Now we are going to look into this, the linked list. What is the linked list? Linked list means it is a representation of a data. I mean, we can store the data in a linked list. For example, assume that this is a node. In linked list, there are two types of linked list. We have single linked list, singly linked list, and double linked list. Now I go with the singly linked list, single or singly, doubly or double. Okay. So in single linked list, the node have two compartments. One compartment is to hold the data and another compartment is hold the reference or memory address of next data. Okay, for example, if I want to save three data, say I want to save A, B, C. Okay, if I use array, how it will be? So I can create an array like this, say A, B, C. So in this case, the array is static. I cannot increase the array size during the runtime. During the runtime, if I get the data, another data D, so I cannot fit into this one. So what I do, I go for linked list. So linked list, so assume that this node memory address is 000. The first data will be here, and I create another node to hold the another data B, and this address is say 001. So here will be the address, so the link will be created, and I create another node to hold the data C, and the C address is 002, and the address of C will be available here, and assume that we don't have a D right now, so this one is a null. So null, null, or just a symbol null. So this is the linked list. In future, if I get another data, say D, how I can insert? First I create a node, put the data, get the reference of this one, and go to the previous node, remove this one, and put the reference memory address of 4. So a new link will be created. So like this, dynamically I can increase the node. I can fit in many kind of data, many unlimited data. But in array, once I declare the size of array, I cannot able to change. So array is sometimes or many times it is called as a static, and linked list is called as a dynamic. Clear? So let me give some pros advantage of a linked list. The very first advantage of link, either singly or doubly. Okay, because the linked list is not the scope of this video, just I'm giving the basic idea of linked list so that you will understand how to represent the tree in a linked list. So I'm not going to explain the doubly because that is not the scope of this video. Now why we go for linked list? The benefit, the first benefit, the advantage is dynamic size. As I told, I can increase the size runtime dynamically. Then efficient operation. So the linked list is efficiently operated. Say insertion is very easy, deletion also very easy. Number 3, dynamic memory allocation. Fourth benefit is the dynamic memory allocation. And it's a third one. The fourth one is easy implementation. Easy implementation. And number 5th point is no wastage of memory. And then we have what is, we can say supports non-continuous memory. Okay, so as you know, during the runtime I can change the size, efficient operator, dynamic memory allocated, easy for implementation, no wastage of memory. Meaning, suppose if I want to use array, okay, so I just declare a array of say 10. Okay, so that means the computer will create continuously 10 memory allocations, 1 2 3 4 5 6 7 8 until 10. Okay, so I have created empty memory space, continuous 10 memory space, but I gonna save only 3 data, say ABC. So ABC will be saved, the rest of the 7 memory will be unused. So this part is a wastage of memory, because always we go for upper hand. If I want to save say 10 data, we usually create array of say 12 or 13 like that. Okay, so that means what we are going for, like a say for scalability. So upper hand will reserve 2 or 3 extra array size, so that if in future we may accommodate 1 or 2 data. So that is a waste of memory. But if you go, that is a waste of memory. If you go linked list, a node is created to hold one data, another node is created to hold another data, another node is created to hold another data. That's it. In future, if we get, then dynamically we can create another node to accommodate another data. So whenever the need arises, we can increase the size. How to increase? Just remove the phi in the end node and refer the memory to the another node. Finish. That's it. We can increase the size. Okay, clear? This is the basic of a linked list. Now we go to tree representation. Tree representation using linked list. For example, I have the tree. Let me erase these extra things. Okay, now I want to represent this linked list in an array form, linked list. Okay, so first create a node. Already your linked list have a node. This is a. Okay, a. How many children A has? 1 2. So create 2 consecutive node. This is for child A, this is for child B and the child C. Now this is the memory reference which points to this node, and this is the memory reference to point this node, and we have one memory reference, it will point this B node, B. Okay, now we have two children. Let me draw like this so that it will accommodate all those stuffs. So I can draw here. So this is a B, have two children D and E. Okay, now D have children? No. So directly put D here. E has children? No. Directly put this one. Sorry, not E. This is not D. This is E. And this is null. Okay. Now, why here we are representing the reference? Because B have children. That's why B is pointed to another node, and we have made the D and E. That's why here like this. So here also C is not a, if suppose for example if we don't have F, what will be happen? We can put C directly here. For D have C have if there's no children. Now in our case C is the parent of F. So what need to do? Here create a reference and point to the C node, and C have children child F. This is null reference. Okay, this is, as I say, what is this dot? Dot in the sense it is a, suppose this is a 0 0 1. See, this is the address 0 0 0 0 0 1 0 0 2 0 0 3. So here what will come instead of dot? This is general representation. Actually it will be like this 0 0 0, sorry, not 0 0 0 0 0 0 1. It points to the this node. And what would be here? Suppose here the B is a 0 0 B address, the node B address 0 0 4 means, so here it will be 0 0 4 will be there, 0 0 2 will be like this. Okay, so if you go to the linked list, you will be understanding better how to represent the memory. So this is how we represent the tree in linked list. Understand? Now we go for another second. Left to child, right sibling representation. Left child, right sibling. Take the same I'm going to explain the, let me erase the extra things. Okay, now here left and right sibling takes doubly linked list. Doubly link in single linked list we have seen two compartment, one is data, one is the address. Okay, it points to the another one. In doubly linked list it will be like this, three compartment, the data will be in the middle, this represents the previous node, this represents the next node. In singly linked list only one direction we can traversal, in doubly linked list two-way traversal. Okay, so for example in singly linked list we have seen A, it points to the B, it points to the C. Okay, right? So in this case this is 5. From A I can go to B, from B I can go to C, but I don't have any reference to come back. I don't have any reference to come back because here we have the address of C, so we go to C. So if we are in C, how do I know where is B? I don't have access to come back. So this is a one-way communication like that. So in doubly linked list it is a two-way. I can say I can create a node like this. A, this address points to the another node, say B, and this one points to the another node C, and this is 5, and this is say this is 0 0 1 0 0 2, this is 0 0 0. So what will be here? Here is the previous node is 0 0 0, the next node is 0 0 2, here is 0 0 1, here is 5. So from here, catching this address, catching this 001 from A, I can go to B. Catching this 002 from B, I can go to C. So here will be 001. And if I want to come back, catching this address 001, I can come back to B, and catching this 000 from B, I can go back to A. So this doubly linked list is a two-way communication. I mean two-way. We can go to and fro. Clear? Now coming to our left right representation, left child and right sibling representation. Here I create a double linked list, but here small changes there. Instead of having side by side, I will put like this. This is a one node to hold. So A have two children, B and C. So this one will point to the node B, and this is left child, right sibling. So you should not create a node like this. You should not create a node like, because this is a left and right sibling. So who is this sibling of B? Sibling of B is C. So C node is created. C node is created. The link must be from the B. So that is called left child, right sibling. Right sibling. B right sibling is C. And then B have again two children. So no. See here, I just made a small mistake. I should draw a doubly linked list, right? So doubly linked list, it is a B, and from here it points to the C. From here it points to the C, and from here we need to come down. Here we have D, and D sibling is E, so it points to the E node, E sibling. So E sibling, nothing. E have no children, so leave it. Now C have one child, F. So from here it points to the left child. Left child is nothing, no left child, but it has the sibling of F. So now F will not, so I can say this one null reference. Say this is null reference, this is null reference, this is null reference, this is null reference, null reference, null reference, and a null reference. Okay, this is how we represent left right child for this tree. Repeating once again, left right child, use doubly linked list. The first one is the node. It has two children. This is a null representation always, and this A have two children. So B, so this is the approach. What is the approach? Is left child, right sibling. So right sibling, we create a link to the right sibling, and B have two children. So from here create one children, and from here sibling of D. Okay, then D have no children, so 5 null reference. E also have no children or no another sibling. For example, if we have another child, say H, okay, how this would come? This will come like this. So E have another sibling, so how it will be represented? So memory is created from here, one new node is created. Here H will be there. H have no children and no next sibling. Clear? This is how we do. And then usually comes to here, we have C have only right child, so no left, so left child is nothing, so it is a 5 null, and this null having right child. Okay, this is the representation. This is the left child right representation. Clear? Understand, guys? See you. Bye bye. Have a great day.